Hello, Professor. My name is Luis Nieto. I'm gonna do my Chapter 27 exam. And I choose a problem 27.1. Alright. For part A, an electron charged negative 1.60, 10 to 19, negative 19 coulombs move at a 2.20 to the 10th, multiplied by 10 to the 5 meters per second through a uniform magnetic field of 1.65 Tesla, pointing at the positive y direction. The velocity lies in the xy plane and is directed 30 degrees to the positive x-axis and 60 degrees to the positive y-axis. Find the magnitude of the magnetic force of the electron. All right. First of all, I have the given data right here. We have the charge. That is negative 1.60, 10 times negative 19 coulombs. Then I have the speed of electrons. That is velocity. So 2.20, 10 times 5 meters per second. Then we have the magnetic field. That is 1.65 Teslas. And the angle is 60 degrees. So, perfect. So the formula that we're going to use, the formula for the magnetic force is F equal to absolute charge multiplied by velocity, multiplied by magnetic field, multiplied by the sine angle. So, perfect. Let's do the formula now. So we have the absolute charge. It's 1.60, 10 times negative 19 coulombs. Then we have the velocity, 1.20, 10 times 5 Teslas, that is 7.65. And then we multiply by the sine angle. Sine 60. Correct. Perfect. So let's get that to the calculator. Put 1.60, 10 times negative 19, put 9. Open parenthesis, 2.20, 10 times 5. .65 Teslas and sine 60. That's giving me 5.03 times 10 negative 14 newtons. Perfect. That's part A. With part B, we have to find the direction of the magnetic force of the electron described in part A. So we know the velocity lies in the xy plane. Magnetic fields is in the positive y direction, and the charge is a negative electron. So we know the velocity and the magnetic field vector give vector pointing in the positive c direction. So since the q is negative, the force direction is in the opposite direction. So this answers, so the direction of the force is in the negative c direction. Perfect. So part C. A charged particle moving in a magnetic field of 0.750 Teslas experiences a magnetic force of magnitude 2.50 10 times negative 10 newtons. The particle speed is 1.95 10 times 5 meters per second at an angle of 36 degrees. to the direction of the magnetic field. Find the magnitude of the charge in the particle. All right, first of all, we have the given data. We have the magnetic force, 2.50 10 times negative 10 newtons. Then we have the magnetic field, 0.750 teslas. We have the speed of the particle, 0.95 10 times meters per second. And they have the angle between vector v and vector v and vector b. So that's angle 36 degrees. Perfect. The formula that we're gonna use is F, the absolute charge, multiplied by velocity, multiplied by the magnetic field, multiplied by angle, sine angle. All right, and we need to get the absolute charge. So pass that, and we leave this. Perfect. So to find the absolute charge, here, we're gonna use 2.50 10 times negative 10. That's a magnetic force. Then we have the velocity. Then we know it's 1.95 10 times 5. Multiplied by magnetic field, so 0.750 teslas. And then the sine, 36 degrees. All right, if we get that to the calculator, 2.50 10 times negative 10 over 1.95 10 times 5, 0.750 sine 36. And that gave me 2. The absolute charge is going to be 2.91 10 times negative 15 coulombs. Perfect. Now we'll go with part D. So for part D, a particle charged positive 3.20 10 times negative 19 coulombs with velocity Vx equal to 3.75 10 times 5 meters per second, moving a magnetic field with only a C component. The magnetic force on the particle is 2.10 10 times negative 15 newtons in the negative y direction. Find the magnitude of the magnetic field. First of all, we're gonna write down the given data, as we always do. We have the charge of the particle, that is positive 3.20 10 times negative 19 coulombs. We have the velocity, that is 3.75 10 times 5 meters per second. And the magnetic force, there's 2.10 10 times negative 15 newtons. Perfect. The formula that we're gonna use for this, it's F equal the charge multiplied by velocity multiplied by magnetic field. All right. Since we're looking for the magnetic field, we're just gonna pass this charge multiplied by velocity. Perfect. All right. So we know. So we know the magnetic force is going to be 2.10 10 times negative 15 over the charge that we got is 3.20 10 times negative 19, and multiplied by the velocity is 3.75 10 times 5 meters per second. Let's get that to the calculator. 2.10 10 times 19 over 3.20 10 times negative 19, 3.75, sorry, 10 times 5, I close parentheses, so I have to go back for a second. All right. And that's giving me 1.75 10 times negative 2 Teslas. Perfect. Now we'll go with part E. So for part E, they're telling us to find the direction of the magnetic field of vector V from part D. Okay. So we know the velocity vector is 3.75 10 times 5 meters per second. The magnetic force is 2.10 10 times negative 15 newtons. And it's in the negative y direction. The charge is positive 3.20 10 times negative 19 coulombs. I'm a little bit stuck here, sorry. Just think a little bit. So, okay, I'm trying to figure this out. Kind of forgot for this one, but okay. So we know the mathematical process for this one. We have vector of magnetic force, charge, plus vector v, velocity, plus vector of magnetic field. We know the velocity. So the magnetic field has only a C component, right? And so I think the F is in the negative y direction when VZ it's greater than 0. Therefore, the direction is of vector V. Vector of the magnetic field is in the positive C direction. Yeah, so I did it right. So the direction of field vector is in the positive C direction. Perfect. Now we go with part F. So let's do part F right here. Part F. For part F, a proton charge positive 1.60 10 times negative 19 coulombs has an initial velocity of 5 10 times 6 meters per second and enters a uniform magnetic field of 0.300 Teslas. The velocity is perpendicular to a magnetic field. Find the magnitude of the magnetic force on the proton. All right. We have the given data. The charge of the protons, it's positive 1.60 10 times negative 1960. All right, we have the speed of the proton, that is 5.00 10 times 6 meters per second. We have the magnetic field, that is 0.300 Teslas, and the angle is 90 degrees because the velocity is it's 90 degrees because the velocity is perpendicular to the field, right? So it's 90 degrees. The formula that we're gonna use for this one is magnetic force is absolute charge multiplied by velocity multiplied by magnetic field and multiplied by the angle. Perfect. All right, magnetic force is 1.60 10 times negative 19. So we have the absolute charge. I didn't explain this on the first part. Look at this part right here. It's negative right here, and here it's positive because it's an absolute charge. So we gotta change that. A lot of people commit errors on that, but it's the absolute, so we gotta change the positive, right? All right, let's continue with this one. So 1.60 10 times negative 19 coulombs. Then we'll go with the velocity, so 5.00 10 times 6 meters per second. And then the Teslas, the magnetic field, so 300 Teslas, then sine 90 degrees. All right, let's get that to the calculator. So 1.60, 10 times negative 19, 5, 10 times 6, 0.300, and sine 90. That's giving me 2.4. So the magnetic force is going to be 2.4, 10 times negative 13 newtons. Now we'll go with part G. All right, for part G, a proton mass 1.67, 10 times negative 27 kilograms, moving in a particular path perpendicular to a uniform magnetic field of 0.300 Teslas with a speed of 5.0010 times 6 meters per second. Find the radius of the circular path. Okay, first of all, we have the given data. The mass of the proton, we know it's 1.67, 10 times negative 27 kilograms. Did I put am I putting the final? Okay, yes, I'm doing that, yeah. All right. The speed of the proton is 5.0010 times 6 meters per second. The charge of the proton, that is 1.60, 10 times negative 19 coulombs. And the magnetic field, there's 0.300 Teslas. Perfect. The formula that we're going to use for this, we're going to use a formula of for radius of circular motion. So it's R equal mass multiplied by velocity over the absolute charge multiplied by the magnetic field. So let's get it to work right here. So the mass we know it's 1.67, 10 times negative 27 kilograms. 5.0010 times 6 meters per second, and over 1.60 10 times negative 19 coulombs multiplied by 0.300. Perfect. So we'll get that to the calculator. 1.67 times negative 27. 5, 10 times 6, 1.60, 10 times negative 19, times 0.300, and that's giving me the radius is 0.174 meters. That's how we got this answer. All right, and that was my exam number 27, chapter 27 exam. Thank you. I hope I did great this time.